Hi everyone, today you're going to be working on your calculator and looking at playing around how to go polar mode and also working on starting your polar project, which will be due next Thursday the 30th. So let's talk a little bit about this project that you're going to be working on. Hopefully by now you should have the worksheet that says the description about it, but let's talk clearly kind of more about what I expect to see for this project. So here are some project details. Obviously the objective is you're going to create a unique design. Don't worry if you don't consider yourself to be creative. You're going to be fine. So whatever you think is a unique design, you're going to graph this on your polar equation on your calculator. And you can choose kind of what equation you want to use and to make your design, but you also get to choose the window setting that's going to make your design look the best. So how are you going to be graded? Well, you're going to be graded on the following criteria. First of all, when you go to create your design, it needs to be a recognizable object as opposed to something abstract. Secondly, you need to create a title for your design. It's pretty simple. Figure out what you're going to draw and then you can create a title if you'd like to. Now, here's where you have to be really careful. I want one single polar equation, not two, not three, just one single polar equation, and that has to be the basis for your design. It can't be the highlight of the design, but it's got to be the major focus of your design. Now, you can choose to embellish this background with other shapes, but the polar graph has to be the focal point of the design. So that this makes this easy, because remember I have to check everybody's polar graph to make sure it's exactly correct, you want to make sure you accurately plot your points for the equation in the polar graph paper that I give you. I need you to be in degree mode, not radian mode, but degree mode. And so to make sure that we all get the same graph, if you set your window based on the graph you're going to plot, it'll work out. And I need you to plot points at least every 15 degrees. If you want to go more than 15 degrees, or smaller increments than 15 degrees, that's fine. But at minimal, it has to be every 15 degrees. So I should be able to see those points on your graph. You don't have to label them, but just definitely plot them so I can see them. And then, if you look at your table settings, if you make sure that your table screen matches the value of your theta value, you can easily quickly plot these points that you need on your paper. So the goal is obviously, once you've got your graph, to fill that polar paper as much as possible. So we use color and design, accent it, add whatever you need to add to it. Your design should be original, complex, and creative. So if you just draw a nice little rose curve and make it a flower, that's not a complex design. It's not highly creative or original, so experiment. This is your chance today to play around with the different curves and things that you could create and get something that will look really cool. Obviously, what you want to make sure you do, because again, you're testing in different equations, as soon as you find an equation that you like, make sure you write it down, and make sure you write down the window settings that you use to produce that graph. That way, if you change your calculator or something happens, you'll be able to recreate it. So as soon as you find one that you like, whether you think it's going to be your final one or not, make sure you record that equation, and of course the graph, the window that you used. So want to see some examples just to get you creatively thinking through some possible examples. Here's some previous past projects that you can see. And you can see, I didn't put the equation on there because I want you guys to be able to create it on your own, but you can see kind of what I'm looking for. If you look at your grading rubric, you'll see that a project is worth 50 points. 50 of those points obviously is a test grade. 40 of those points are going to be used based on the project criteria, and the remaining 10 points are going to be graded on the self-reflection questions that you're going to answer after having completed this project. The self-reflection questions are on the back of your sheet, and so things I want you to think about, when you're doing this process today. In what ways did you experiment mathematically while working on this assignment? What did you learn from doing this assignment? And did you enjoy working on it? Why or why not? I want some in-depth, honest answers for these. I don't want them to be very simplistic, saying, well, I learned how to graph polar coordinates. No, that's not what you learned from this. We already knew how to do this. I don't want you to say, oh, I learned that if I add this equation and this equation, I get this equation. Be more specific. Talk about some ways experimenting mathematically, not just saying, well, I multiplied by 3 and I got a bigger graph. Think about some things that you were learning that you haven't done before when you're looking at this assignment. And it's fine to say that you didn't like the assignment, but just tell me why not. So here's some examples. This one was called Prom Date. Again, you can see the equation that they used here and the window that they used. This one was called Furious Frantic Fishy in Blurry Bowl. This one was Miss Piggy. And this was with the Wicked Witch at the North Pole. And rounded out Pikachu. So what you want to see is that when you looked at these graphs, all of these, the major focus was the actual polar graph. And then they used color and everything to highlight and just kind of make it look really pretty. But that should be your goal as you're working through this. So have fun playing around with the examples to try and get yourself practicing and getting comfortable using this polar mode. And like I said, you may not find the first or second or even the 10th equation that you come up with to be the one that you want, but keep playing around with them and make sure that you find one that you're happy with. And once you've got it down, write it down and then work with it to plot it. Remember, you want to plot every 15 degrees. That's why I've labeled your graph paper based on degrees. And just do your best. The key thing is when you graph it by paper, it should look very similar to what you had on your calculator. So make your scale in your calculator be similar to what you have on your paper, and you should be good to go. Have fun!